Today we will be classifying rational numbers. We have 4 definitions to go over. The first definition is natural. A natural number, the definition states a set of all positive counting numbers. They are the numbers on the number line starting with number 1. Some examples would be, for example, 42. Another example is 50 over 2. 50 over 2 really equals 25, so that's why it would be a natural number. And another example would be 800. Our second definition is whole numbers, the set of all positive counting numbers starting with 0. So our whole numbers are going to be 0, 1, 2, 3. Next definition is integers, the set of whole numbers and their opposites. Opposites is a word that you should remember from last year as well, in addition to these definitions. Integers could be, example, -1 and -50 over 2. -50 over 2 is equivalent to -25, so that would be an integer. Rational numbers, numbers that can be written as fractions, terminating decimals, repeating decimals. So some examples are 12, 5/7, -6.8, 3.4 repeating, 9 over 11. So typically, in 7th grade, we see rational numbers. Every number is classified as a rational number. And then we could look into integers. Integers are going to be the whole numbers and their opposites. Whole numbers start with 0, and natural numbers begin with number 1. We're also going to take this box, and from the examples above, we are going to fill in our box. We are first going to write in rational numbers. Integers. Whole numbers. And natural numbers. So these are just our definitions. Our broader definition is rational numbers. So let's go ahead and categorize numbers. We're going to start with our first example, which is number 42. We said all numbers are rational, so we know 42 would fall in this category. Now we need to love this 42 an integer. And yes, 42 is an integer. Is 42 a whole number? That's correct. So the last bucket we're looking at is a natural number. Does 42 fall in natural number? And that is yes. So 42 will be in there. Our next example was 50 over 2. And if you recall, we said that 50 over 2 is equivalent to 25. All numbers are rational, so we know it goes here. And we know it's an integer. And it's also a whole number. And therefore, 50 over 2 would be a natural number. Our last example was 800. Again, they're all rational. It's an integer, it's a whole number, and it would fall in this example as well under natural numbers. So when we're writing them, we're not writing it in all the different places. We're actually writing it where it ultimately would land. So our next examples were 0, 1, 2, and 3. They're all rational. They're integers, and they're whole numbers, so they would look like this: 0, 1, 2, 3. Then we had integers, which were -1 and -50 over 2. Remember, -50 over 2 we said was equivalent to -25. They're they're rational numbers, so we know they go in here, but they're also integers because that's how we classify them. So it's -1 and -50 over 2. The last group we classified as rational numbers. So the very first one we had was 12 and 5/7. Since it has a fraction and that fraction cannot be simplified, it stays here under rational numbers. Then we have negative 6.8. Again, that is a decimal. Everything's a rational number, and it's not an integer because integers don't have decimals or fractions. The next one was 3.4 repeating. We know it's rational. Again, not an integer because of the decimal. And then the last example we had was a fraction. The fraction is 9 over 11. It's a rational number, not an integer, because as a fraction, it can't be simplified from that, so it can't move to another category.
So